Welcome all of you to another video of Maths Made Easy. Now in this video we are going to do Indices 9th standard topic, 9th ICSE topic. Okay, so this is one chapter where sometimes it feels students find it little tough, some of the problems. Till the end of the video, if you see till the end of the video, I have taken up all different types of questions. So please see till the end of the video. Okay, this is then you'll get all the types. In fact, in all my videos, I try to take all the different varieties of questions in that chapter. Okay, also if you have not subscribed my videos by now, my channel by now, please subscribe it because lots of more topics are going to come up. Okay, go through my playlists. You can see playlists of physics and maths ICSE separate playlist is there, CBSE separate playlist is there. Okay, so please go through the playlist and you'll get lots of more videos for 9th ICSE too. So let us start quickly. Now what are indices? Indices are nothing but exponents only. They are close to exponents. Only thing is exponents you do till 8. Indices in 9th standard takes up a little more difficult form. Okay, so all the rules of exponents that we used to do will be applicable here also. Like a to the power m into a to the power n, base is same, then the powers get added. If it is multiplication here, if it is addition here, nothing can be done. A to the power n by a to the power n, that is a to the power m minus n. Again, a to the power m to the power n is a to the power mn. Okay, a to the power m, if I want to write in the denominator, I will have to write like this. Okay, if I already have it in the denominator, I will have to bring it to the numerator with a minus. So you take it up and down. Okay, you take it to the from the numerator, you take it to the denominator, there is a change in sign. Okay, any number to the power 0 is always a 1. A to the power m into b to the power m, note this, bases are different, powers are same, is ab to the power m. So these are few of the rules. Okay, 1, 2, 3, 4, 5 and you can say 6. Okay, 6 of the rules of this chapter. But for this entire chapter will be following these rules only. So you can look back, you can copy down these rules and you can look back as I do a sum. You will definitely find one rule which is being followed there. Okay, so let me quickly start. So here there is one question which says evaluate. Evaluate simply means find the value of. So 3 cube into 243 is a 3 into 3 is 9, 9 into 3, 27, 27 into 3, 81, 81 into 3. So 3 to the power 5, okay, minus 2 by 3 into 3 minus 2 by 3, because this is 3 square is a 9, so this 2 went here. Okay, everything is to the base 3 now, so it is easy for me. Minus 10 by 3 minus 2 by 3, which is 3 to the power, okay, 9 minus 10 minus 2 by 3, which is 3 to the power minus 3 by 3, 3 to the power minus 1, which is 1 by 3. Okay, so this is the final answer. So here I did an LCM and I got an LCM as 3, then I simplified, I got 1 by 3. Okay, next question, let's see. Next question is, we just have to simplify this, 8x cube. Now this can be written like this, and 5 of y, okay, and I can write, okay, 125 only, and to the power 2 by 3, which is equal to 2, this is 2 cube, okay, 2x, 2 cube x cube. Okay, so what I do here is put the cube here into 2 by 3 because both are cubes, and 5 cube and y cube, sorry. Okay, so this is cube, this 5 cube y cube, I take it outside the bracket into 2 by 3 again, 3 and 3 cancels, which is equal to, now this is 2 square x square, that is 4x square by 25y square. Now we cannot simplify it any further, we'll have to stop here. Okay, now here is a question which says evaluate. This question I can say is the most very important, very important question always asked in the exams, and this comes to for about 2 to 3 marks. Listen carefully. Now when they say evaluate, there is an unknown here, which is the unknown variable n. We don't know the value till the end of the sum. What to do? Okay, so somehow we have to throw that value out to get a proper number. Now what to do here is 5 to the power n, 5 cube minus 6 into 5 to the, this is I am doing using laws of exponents only, okay, the first law, and I am going from the other end, that is base is same, products exponents are added. 3 square into 5 to the power n minus 5 to the power n into 2 square. That is, now we take the 5 to the power n, okay, we take the 5 to the power n out from each one of them in the numerator and in the denominator. Okay, how much do I get? This 5 to the power n cancels out. So I have completely removed the unknown variable n. Now I have only numbers. So that is equal to 95 by 5, which is equal to 90. Okay, so this is my answer. This you'll find in your textbook very commonly. Now here it says simplify. Simplify is we will start with the innermost bracket, and till we have not finished with that, we will not touch the outer brackets. So here 1 by 1 minus n and minus 1 minus 1. This is 1 minus n minus 1, 1 minus n, and this is minus 1. Okay, this goes. So here 1 minus, and now here I'll have to give it a reciprocal. See, I'll have to give it a reciprocal because I have this minus 1. 1 minus n by minus n. Okay, I am done with the minus 1 sign. So minus 1 now, but I still have this minus. Okay, so what I do now is this makes it plus n plus 1 minus n, because it is made plus with this, and here n because minus is used up. Okay, to the power minus 1, which is this goes. Okay, so my answer is just an n, because 1 by n to the power minus 1. Okay, if you want me to write like this, I'll write to the power minus 1, which is equal to n. Okay, so I have got the final answer, which is just a n. So you have to be very careful in this sum. This one I started with the innermost bracket, gave the reciprocal because of this minus 1. Okay, then I worked inside the bracket only. I didn't move out of the bracket till I have simplified this completely. Now I simplified it, I still had the minus 1, then I did the reciprocal, but I still kept this intact. This minus multiplied with this, okay, gave me a plus. Then I simplified further inside and then gave it a reciprocal. So very important questions. Now here is one question again. If 2160 is 2a, 2 to the power a into 3 to the power b into 5 to the power c, you have to find abc, and after you get the values of abc, you have to find this value. Okay, so what we do first is 2160 here 2. Okay, 1080 2, 540 2, 270 2. Okay, 135 add a 5, this is 27, then 3, 9, 3 and 3. Now this is the prime factorization of this number. So whenever you get a sum like this, you do prime factorization of this first, of the big number first, and then I can write like this. 2160 is 2 to the power 4, 1 2 3 4 into 3 to the power 3 into 5 to the power 1. Okay, so a is equal to 4 and b is equal to 3 and c is equal to 1. Okay, so 3a into 2 to the power minus b into 5 to the power minus c. Okay, that is 3 to the power 4 into 2 to the power minus 3 into 5 to the power 5 to the power minus 1. That is, this is 9 into 9, 81, 81 by 8 and 5 here, 81 by 40. Okay, this comes down 8, 5 comes down, and 3 into 3 is 9, 9 into 3 is 27, 27 into 3 is 81. So as you do more practice, you'll start remembering these things. So I have, this was my ABC, and then I found this extended sum I have found here. So my final answer is 81 by 40, and these are the values of A, B and C. Let's do this. They have told simplify. So here this is 2 cube. So 2 cube, if I write, if I make it base 2, then it becomes 9A, because okay, into 2 to the power 5 into 2 to the power 2A. Do you see all of them have become base A? 2 square into 2 to the power 11A into 2 to the power minus 2A. All base 2's. 9A plus 5 plus 2A. This is 2 plus 11A minus 2A, which is 2 to the power 11A plus 5, 2 to the power 2 plus 9A. That is equal to 2 to the power 11A plus 5 minus 2, okay, minus 2 minus 9A, okay, that is equal to 2 to the power 2A plus 3. 2 to the power 2A plus 3 is the final answer. So what I did, I took it to the numerator, everything changed to minus sign, and then I simplified a little bit. 11A minus 9A 2A, 5 minus 2 is a 3. So I have used all laws of exponents. Here I have used the first rule, base is same, all powers get added. So you just have to keep your eyes open. You have to see, okay, can I make these to the base 2? If you can, then use the first property of indices. Evaluate. Very commonly asked question. There are few more types of this you must have seen. Usually asked at the end of the question paper. They will ask it in the when they have to give more marks. Okay, so it will be 3 to 4 markers. Okay, so how to do this? X to the power A minus B. Again, this denominator I pick up, it becomes minus B. And here the writing style is important. You write it properly, you get your sum right. Okay, B minus C. Again, I use that rule of indices. B square plus BC plus C square into X to the power C minus A, C square plus CA plus A square. Okay, now if you know this rule, A cube minus B cube is A minus B, this identity. A square plus AB plus B square. This is the identity I am going to use here. A minus B, you see the same thing. B minus C, there's a minus here, there's a plus here. There's a minus here, there's a plus here. So it is actually following this identity. Okay, so here I am going to write A cube minus B cube X B cube minus C cube X C cube minus A cube. Now all bases are same. I'll add the exponents. B cube plus B cube minus C cube plus C cube minus A cube. Okay, that is X to the power 0, that is equal to 1. That's my final answer. Okay, so this was it from indices. This is indices part 1. Okay, so there are lots more sums to come up in indices that will come in indices part 2. So please check the video sequentially, you'll understand it better. Okay, so if you have liked the video, do not forget to like, share and subscribe, and also comment. Do not forget to comment. Okay, I'll be waiting for your comments. Any doubts you can ask in the comment section. Thanks all of you. Bye then. See you in indices part 2. Bye.